Good day, my amiable viewers. You are welcome back to class. My name still remains Israel Gwa. Today we have a very important topic we are going to talk about. Most likely, as I'm saying, most likely you will encounter a lot of questions from this, if no more than two. Remember, your number of questions in chemistry is 40, but you may likely encounter questions. I'm very, very sure because it's very, very important aspect of chemistry. And Jamb are so much interested in all this. So just listen very, very well. Try to understand it very, very well. If you have any challenge, please go to the comment section and by God's power, I'll go to explain, answer any of your questions. This topic, once again, is very, very important, especially this your forthcoming Jamb. However, even after the Jamb, all the topics you are putting in Jamb, they are done little by little, so that you're able to easily go through them because they are selected, properly selected. And more topics will also be coming. Please always do well to check this channel and also like it. Don't just be watching alone. So share it to your friends and also subscribe. Like this topic we are going to discuss today is on a particular equation. Questions most likely come from this and also from your WAEC. Explain the effect of temperature pressure on the following reactions. So you look at the write the reactions out. Remember, you don't need to waste too much time. SO2 plus O2 to give you 2SO3. It's in gaseous form, gaseous form, gaseous form. Enthalpy equals negative. That is what you put here. This is what is in the question. However, we are still going to consider the aspect that require positive enthalpy, so that in whichever way they twist it, you go to come out of it successfully. Now, explain the effect of temperature. You should not take your time. Remember, temperature affects a system in its own way. Increase in temperature causes the reactants to accumulate energy and so increase their kinetic energy, making it to move faster. That is the normal explanation for, when you acquire kinetic energy, the motion become present and collision increases, making the reaction to be faster. But in this regard, that is not what they are looking for. Once you see temperature, increase the temperature, go straight to this place. Delta H is negative. A reaction that is already giving out heat does not require increase in temperature. Therefore, because they will tell you to explain this, how it affects on equilibrium mixture. That's what you'll be told. Explain this, how it affects equilibrium mixture or equilibrium reaction, whichever way, because system is already in equilibrium. So you just go to this triangle H, enthalpy change. If you see that it's negative, just know that increase in temperature will not favor the forward reaction. Increase in temperature will only favor the reverse reaction. Remember, any side that is favored, that is where equilibrium constant will go. Since this reaction will not favor the forward reaction, equilibrium constant will not shift to the forward reaction. It will only favor the reverse reaction. Therefore, equilibrium constant will go to the reverse reaction to favor the backward reaction. More product because heat is already given out. Consider when something is very hot, you don't need to increase more heat, you reduce the heat. So that is how it affects it. For exothermic reaction that is already giving out heat, you have to calm it down because increase in temperature will not favor. They will ask you, they will specify it, increase or decrease. But for this kind of reaction, because it's already giving out heat, decrease the temperature will favor the forward reaction. More product will be formed. You see, more of your product will just be formed. That is how temperature affects this system. That is what will be required of you. So, for example, now they say delta H equals positive. This is a different reaction entirely. This one, heat is absorbed from the environment. Heat is absorbed. Because heat is absorbed from the environment, if you increase the temperature, more product will be formed. More of the product will be formed. More product, sulfur 6 oxide, will just be formed because you are increasing the temperature. Increase in temperature favor this side, the forward reaction. Equilibrium will move to the forward, to the side of the product because it is being favored. But decrease the temperature will favor the reverse reaction. That is how this system goes. Once you have temperature, don't forget, don't consider number of moles or any other thing. Just for Jamb, just go straight to the charge carried by the most, include it. Enthalpy change, either positive or negative. Go straight to that charge and don't waste your time because it's very cheap. So that is how that one goes. Now we are through with the first one. See, it's very cheap. Let's return it back to delta H equals minus. Now they may put this, but usually they don't put it because they cannot ask you the two questions at the same time. In objective, it's only one at a time. It's only a while they will tell you to write short note on this, what will be the effect of increase. You now have to write. Don't forget, what I just wrote is what the examiners will be looking for to tick. If you write something else, you will not get any mark. I said maybe for this particular question, this is what you should write. Now, if you have this one, they said, what is the effect of pressure? But they will specify it. This one was placed so that it be generalized. Effect of pressure. They will not just ask what the effect of pressure is, because that is not a sound question. They will say, what is the effect of increasing the pressure? They must specify that. Increasing or decreasing the pressure. It's not tedious. What you need to do, once you hear pressure, you ignore this one. You just know that this one is either to deceive you or to cause distraction. What you just consider is the number of moles for gaseous molecule. Remember we said in the other video that equilibrium constant affect only gas, it doesn't have business with solid. I'll give you an equation that involves solid some other video. So like this now, number of moles here is 2 moles, which is gaseous. You must check it gaseous. Number of moles here is 1 mole, which is also gaseous. Number of moles here is 2 moles, which is also gaseous. So if you add this to this one, become 3 moles, while this one still remain 2 moles. This is what will guide you. Once you have knowledge of this, you have got the answer. Increase in pressure will favor the side that have the lesser mole. Don't forget that. Any side the moles are smaller, you have opportunity to feed it. So increase in pressure will favor the side that have the lesser mole. Therefore, in this kind of reaction, the more you increase pressure, the more the forward reaction. More product, more product, more product, because this side have lesser mole. Equilibrium constant will move to the right. You see it. Any side that is winning is where it goes. Don't forget that. Then decrease in pressure will favor the side that have the higher mole. So if you decrease the pressure, to favor the backward reaction. You see, this side will favor, the reverse reaction will favor. Equilibrium will move to the left. That is all about pressure. Just consider number of moles and on the gaseous molecule on the left hand side compared to that on the right hand side. Remember also, the 2 conditions necessary for pressure to affect this system is one or more of the reactants and of the product must be in gaseous form, in case you are asked in your WAEC or even Jamb objective. Second one is that the number of moles of the gaseous molecule on the left hand side must not be equal to that on the right hand side. If it's equal, pressure will not have any effect. We'll deal with that one some other videos. Then the last question: what happened to the, let's remove one. What happens to the equilibrium system if oxygen is removed? This one is actually telling us about concentration. You see the way they twisted it. And in your textbooks, they will ask, what is the effect of concentration? In real life Jamb, they don't have time for that. They don't have time for that like that. They want application. This is chemistry application. They say, what happens if oxygen is being removed? What you need to know is that whichever side they remove anything, according to the Chatterton's principle, which states that when a system in equilibrium is subject to constraint, that destabilization, constraint, such as change in temperature, change in pressure, or change in concentration, the system will readjust itself to restore back equilibrium. That answers it for you. If oxygen is removed, more of the product will be reacting, and refeeding it, reacting to refeed it. Once the system is equilibrium is restored again, you have equal number here to this side. The system will continue, the reaction will be stabilized. So any side that one or more of the moles or one or more of the reactants is removed, the other side will feed it. That implies that if oxygen is removed, it will favor the backward reaction, because this side will be producing more and more, reacting with this side to release this side of the strength or constraint. So more oxygen will now be produced. So it will favor the reverse reaction. That is when oxygen is being removed. If it is in the product side, maybe you have this plus another one, the side, whichever side they remove, that's the side that it will favor. Equilibrium move to that side, because more of that product will be formed. That's all we can take for today. So you have answered the question. Please settle down properly and go through all these things again. God bless you as you continue to share this video, and also subscribe if you have not been doing so. Thank you.